Welcome, everyone. Ready for another deep dive?
Always.
Okay, well, today we're tackling domain-driven design.
DDD.
Yeah,
I
exactly.
love it.
We had a listener send in some excerpts from Implementing Domain-Driven Design by Vaughn Vernon.
Oh, great book.
It is, and I think this is a good sign that our listener wants to go beyond just the theory.
Right, they're ready to really dig in and apply these concepts.
Yeah, so let's do it. Let's unpack DBD and see how we can make it work in the real world.
Sounds good.
Okay, so first things first.
Yeah.
What's all the hype about with DDD?
Well, I think one of the most powerful aspects of DDD is its ability to bridge the gap between business experts and developers.
Right, because often it feels like they're speaking completely different languages.
Exactly. The business folks are talking about products, customers, orders.
And the developers are all about databases, algorithms, code.
Yeah, and that disconnect can lead to all sorts of problems.
For sure, like misunderstandings.
Misunderstandings, software that doesn't actually meet the needs of the business.
Ultimately, frustration on everyone's part.
And that's where this idea of a ubiquitous language comes in.
Okay, ubiquitous language. Tell me more.
It's all about creating a shared vocabulary, a common ground where everyone understands each other.
So it's like building a bridge between those two worlds.
Exactly. So you have product owners, developers, stakeholders.
And everyone on the same page, speaking the same language.
Right. And that's where DDD really shines because it encourages us to build our software in a way that reflects that shared understanding.
That's fascinating. But how does this shared language actually show up in our code? Is it just about using the same words in comments and documentation?
It goes much deeper than that.
Okay, I'm intrigued. Tell me more.
Without DDD, you risk ending up with something called an anemic domain model.
Uh-oh, anemic domain model. That doesn't sound good.
It's not. It's like having a collection of cowboy boots that are just described by their physical attributes,
Like the leather, the stitching.
Pointy-toed, all that.
But you're missing the essence of what makes them cowboy boots.
Exactly. Their function, their role in a cowboy's world.
It's like you have the form but not the function.
Precisely. And in an anemic domain model, your objects are just data containers.
Okay, so they hold information but they don't really do anything.
Right. All the crucial business logic is scattered and disconnected.
So instead of having code that reflects the vibrancy of the business domain, you end up with a bunch of empty shells.
Exactly.
Okay, so how do we avoid this? How do we bring those cowboy boots to life, so to speak?
GDD guides us to design objects that don't just hold data, but also encapsulate behavior and logic.
So we're moving from data-centric to behavior-centric.
Right. And this makes your code a reflection of the business processes themselves.
It's like giving those cowboy boots the ability to walk, ride, withstand the rugged terrain.
Exactly.
That's a fantastic analogy. Can you give me a more concrete example? Like, how would this actually play out in the code?
Okay, so let's say you're working with backlog items in an agile project management system. Instead of just changing a backlog item's sprint ID and status independently, you might define a method like commit a sprint.
Okay, that makes sense.
That encapsulates the entire process and ensures data integrity.
So it's not just about updating data, but about modeling the actual actions and workflows of the business.
You got it.
This makes a lot of sense, and it seems like it would lead to code that's much more intuitive, more maintainable.
Absolutely.
Would you say this aligns with agile methodologies?
Absolutely. DDD is not a rigid top-down methodology.
Right, it needs to be adaptable.
Yeah, it thrives in agile environments.
Okay, so it works well with those iterative, incremental approaches.
It does. It encourages continuous refinement, supports practices like test-driven development.
So we're constantly adapting, refining, evolving the model as we learn more.
Exactly. And it's important to note that DDD is not just about individual objects. It also gives us a framework for organizing our entire system.
Okay, and how do we do that?
That's where the concept of bounded context comes in.
Bounded context. Okay, I'm ready. What are those?
Think of bounded contexts, like drawing clear boundaries within your application.
Okay. Boundaries like fences in the real world.
Exactly. Fences that define specific areas where certain terms and models apply.
So for example,
Like in an e-commerce platform, you might have separate bounded contexts for ordering, inventory management, customer relationship management.
each one with its own set of rules.
Its own language, its own business rules, its own model.
So it's like breaking down a complex system into smaller, more manageable units.
Yes, but it goes beyond just technical separation. It's about aligning your code with the realities of the business domain.
Got it. So it's not just about technical divisions, it's about reflecting those deeper distinctions within the business itself.
Exactly. And the book has this great example from Sessivation. Remember, they're building this collaboration software.
Yeah, I remember them.
Initially, they made this mistake of combining user and permission concepts with their collaboration context.
It seems logical at first.
You'd think so, but it led to complications when they tried to implement things like role-based access control.
Ah, because those are actually distinct concepts with their own specific rules.
Exactly. They realized that users and permissions deserve their own separate bounded context.
It's like trying to fit a square peg in a round hole.
Right. Keeping those contexts separate makes the model clearer and prevents unintended consequences when you make changes.
So it's all about defining those boundaries carefully.
Yeah. And to help with that, Vernon introduces this concept of context maps.
Context maps, what are those?
Think of them as a blueprint for how different parts of your system communicate and interact.
Okay, so it's like a visual representation of those boundaries and relationships.
Exactly. And this naturally leads us into the realm of architecture because DDD has a lot to say about how we structure our systems.
Now, when I hear the word architecture, my mind immediately jumps to those rigid plans and those waterfall methodologies.
Right, I know what you mean, but DDD actually embraces a much more flexible and adaptable approach.
Okay, so it's not about forcing us into a one-size-fits-all solution.
Not at all. The book explores all sorts of architectural styles that can work with DDD,
Like what?
like hexagonal architecture,
Hexagonal.
service-oriented architecture,
What?
CQRS, event-driven architectures,
Hmm?
even data fabrics and grid-based systems.
Okay, so it's not about dictating a specific architecture, but about understanding the principles that guide effective design.
Exactly. There's this fictional interview with the CIO in the book who describes how Sathovation's architectural choices actually evolved over time as their business needs changed.
So it's about being adaptable, responding to those ever-changing requirements.
Exactly.
Okay, so it's all about striking that balance between structure and flexibility.
Yes.
But with all these different approaches, are there any core architectural principles that really shine through in a DDD context?
There are, and one that stands out is this concept of hexagonal architecture, also known as ports and adapters.
Okay, hexagonal architecture sounds intriguing. Tell me more.
This approach is all about decoupling your core domain logic from all those external concerns,
External concerns like what?
like databases, user interfaces, third-party services, anything that's not part of your core domain.
So it's about creating a clear separation between the essential business logic and all the technical details of how things actually get done.
You got it.
So how does this decoupling actually work in practice? I mean, hexagonal architecture sounds a bit abstract.
Imagine your core domain logic as if it's sitting at the center of a hexagon.
Okay, a hexagon, got it.
Each side represents a port, which is a point of interaction with something external.
So like a doorway in or out of the hexagon.
Exactly. And for each port, you have an adapter that acts as a translator.
So the adapter converts between the outside world and the language of your domain model.
Exactly.
This is brilliant. It's like having a universal translator that allows our system to speak to databases, user interfaces, APIs, all without cluttering our core logic with those implementation details.
Precisely. And this makes your code more testable,
Right, because you can easily swap out those adapters.
more adaptable, more resilient to changes in technology or business requirements.
This is incredibly valuable, and I can see how it aligns perfectly with that idea of keeping our domain logic pure and focused.
Exactly.
Now, while hexagonal architecture provides a solid foundation, I'm also curious about how specific communication styles fit into the DDD world.
Yeah.
Like REST, for instance. I mean, it's so ubiquitous these days. How does it play with DDD?
REST, with its approach of treating everything as a resource, really aligns beautifully with DDD's focus on modeling your domain in terms of objects and actions.
So it encourages us to think beyond those basic serial operations.
Right. It's about designing APIs that truly reflect the actions and workflows that are meaningful within our domain.
So it's about creating interfaces that are expressive, that tell a story.
Exactly. This is a shift from data-centric to action-centric API design.
I like that action-centric API design. It just makes
It
sense.
does.
Okay, so we've discussed those high-level concepts, bounded contexts, architecture. But what about the nitty-gritty of building that rich domain model?
Right. Let's get into the details.
What are those fundamental building blocks that we should be using?
Well, Vernon introduces these 4 core tactical patterns: entities, value objects, domain services, and domain events.
Okay, 4 key ingredients. I'm ready to learn about each one.
All right, so let's start with entities.
Entities, okay.
These are objects that have unique identity that persists over time.
So like a customer in an e-commerce system,
Exactly. Each customer has a distinct ID,
a history of orders.
unique data that sets them apart.
They're not just defined by their attributes at any given moment.
Right, so even if two customers share the same name and address,
They're still distinct entities.
because they have different identities, different histories.
Okay, so identity is key here.
It is. And this distinguishes entities from another essential building block, value objects.
All right, value objects, what are those?
Think of these as immutable concepts defined entirely by their attributes.
So they don't have that persistent identity like entities do.
Right. Take currency, for example.
Like dollars, euros.
Exactly.
Yeah.
Instead of representing them as simple strings or numbers, you'd create a currency value object.
Which would encapsulate the currency code, the amount.
Any formatting rules, this makes the meaning crystal clear and ensures immutability.
So once you have 100 USD.
It always represents that exact value. It can't be changed.
Okay, so entities have identity, value objects don't, and both are vital for modeling our domain.
They are.
What about those domain services you mentioned? Where do they fit in?
These come in handy when you have logic that doesn't naturally belong to an entity or a value object,
Give me an example.
like calculating shipping costs in an e-commerce system.
Okay, so it's not inherently part of the customer or the product.
But it's still essential to the domain.
So you'd create a shipping cost calculator domain service to handle that logic.
Exactly. This keeps your entities and value objects focused and ensures that complex logic is well organized.
All right, and the final building block.
Domain events.
Okay, domain events. What are we talking about here?
These capture significant occurrences within your domain, like a customer placing an order.
Or a product being added to inventory,
Exactly. And these events can trigger other actions or processes.
creating a ripple effect throughout the system.
That's the idea.
This is incredible. We've gone from high-level concepts like bounded context and architecture down to these very specific building blocks.
We've covered a lot of ground.
I feel like we've just scratched the surface of DDD. There's so much more to explore.
There is. And in the next part of our deep dive,
Yes.
we'll uncover even more of the intricate details and powerful concepts that make DDD such a compelling approach to building robust and adaptable software.
Okay, I'm ready. Bring on part 2.
All right, welcome back.
All right, ready for more DDD?
Absolutely. We're going to tackle a concept that's both powerful and often misunderstood.
Yeah.
Aggregates.
Aggregates. All right, I've heard the term before, but honestly, I'm still a bit fuzzy on what they actually are and why they're so important.
Yeah, it's one of those things that can be a bit tricky to wrap your head around at first,
For sure.
but they're crucial in DDD, so let's try to demystify them.
Okay, I'm all ears.
Remember how we talked about entities and their unique identities?
Yeah, each entity has its own distinct ID, its own history.
Exactly. Well, aggregates build upon that concept.
Yeah, okay, so how?
They're essentially clusters of objects that we treat as a single unit, especially when it comes to data consistency in transactions.
So instead of thinking about individual objects in isolation, we're now grouping them together into these cohesive units.
Exactly. It's about understanding how these objects relate to each other and how they interact as a whole.
I'm starting to see the bigger picture here, but I still need a bit more concreteness. Can you give me a real-world example?
Absolutely. The book shares a cautionary tale from Sasvation's early experiences with DDD.
Oh, a cautionary tale. I love those. What happened?
Well, they initially modeled their product concept as this massive aggregate.
Okay.
It encompassed everything from backlog items and releases to sprints and tasks. It became this huge, unwieldy monster.
Oh, no. I can see where this is going.
It caused all sorts of performance problems, consistency, nightmares.
Trying to keep all of that in sync must have been a nightmare.
It was. They learned the hard way that designing these massive, large cluster aggregates is a recipe for disaster.
So the lesson here is to keep our aggregates small and focused.
Exactly. Vernon emphasizes the importance of defining clear consistency boundaries and avoiding those mega aggregates.
So how do we determine those boundaries? How do we avoid falling into the same trap as Sasvation?
Great question. Vernon offers some helpful rules of thumb.
I'm all about rules of thumb. Lay 'em on me.
All right, first you want to focus on those relationships that must always hold true, not just things that happen to be related.
So genuine invariance of the domain.
Exactly. For instance, in an e-commerce system, you might have an order aggregate. It makes sense for an order to always have a customer associated with it.
Right, that's an invariant. An order can't exist without a customer.
Precisely. But you wouldn't necessarily include things like the customer's entire purchase history in that aggregate.
So it's about including only those elements that are essential to maintaining the consistency of the core concept.
You got it. Another rule is to design small aggregates whenever possible.
Okay, smaller is better.
Smaller means more manageable, better performance, less risk of those consistency headaches.
Right. Constantly loading a massive aggregate into memory would definitely slow things down.
For sure. And when you do need to reference objects from one aggregate to another,
Yeah.
always do it by identity, not by holding a direct object reference.
So instead of an order object containing a full-blown customer object,
Right.
it would simply store the customer's unique ID.
You got it. This maintains that loose coupling and scalability we talked about earlier.
It's all about those connections, those relationships between different parts of the system.
Exactly. And it also plays into another important rule, embracing eventual consistency outside of the aggregate boundary.
Okay, eventual consistency. Now, this is a term I've heard before, but it always makes me a little nervous because it implies that things might be temporarily out of sync,
It does, but it's often a necessary trade-off in complex systems.
especially in distributed environments.
Especially in distributed environments, trying to force immediate consistency everywhere can really bog things down.
So it's about finding that balance between consistency and performance.
Yes, ensuring that those critical invariants are enforced within aggregates, but allowing for some flexibility in how data is updated across the system as a whole.
So we're loosening the reins a bit
In a controlled way.
in a controlled way, yes.
And this is where those domain events we talked about earlier can really shine.
Oh, right. Domain events, they're back. How do they help us manage this whole eventual consistency thing?
So when a significant event occurs within an aggregate, like an order being placed or a product being shipped,
Yeah.
it publishes a domain event. Other parts of the system can then subscribe to these events and react accordingly, but not necessarily at the exact same moment.
So it's like setting up a network of listeners where different parts of the system can respond to changes as they happen, but without creating those tight dependencies that can cause bottlenecks.
Precisely. This allows you to update different parts of the system asynchronously, which can really enhance flexibility and scalability.
This is incredibly powerful. It's like we're building a system that can adapt and evolve organically.
Exactly. But we can't forget that at some point, we need to persist all of this data.
Right. We've talked a lot about objects and their relationships, but they don't just float around in memory forever. We need a way to store and retrieve them.
Exactly. So what guidance does DDD offer when it comes to interacting with databases and handling persistence?
That's a great question. What does it say?
It says use repositories.
Repositories. Okay, another new term for the glossary. What are those?
They act as a domain-centric abstraction over your persistence mechanism.
So instead of our domain objects talking directly to the database,
Right.
we use a repository to handle all of those gritty details of storing and retrieving data.
Exactly. This keeps your domain logic clean and focused and decoupled from the specifics of your chosen persistence technology.
Okay, I like it. It's like having a dedicated translator for each aggregate.
Exactly.
But how do these repositories relate to those aggregates we were just discussing?
That's a great question. A key principle in DDD is that repositories work with aggregate roots,
Aggregate roots.
not individual objects. So you wouldn't have a separate repository for every single type of object in your domain.
Okay, so if I wanted to retrieve a specific task object, I wouldn't go directly to a task repository.
Correct. You would go to the repository for the aggregate root that contains that task, like the backlog item repository.
So the repository acts as a gateway to the entire aggregate.
Exactly. It ensures that we're always working with a complete and consistent set of objects.
This makes perfect sense. The repository enforces that consistency boundary. It's like a gatekeeper for the aggregate.
I like that, a gatekeeper. And the book explores different ways to implement these repositories.
Depending on the type of database or persistence technology we're using.
Exactly. So we're not limited to just relational databases and ORMs like Hibernate.
What are some other options?
Vernon talks about using technologies like coherence,
Coherence.
which is a distributed data grid, and even MongoDB, which is a document database.
So there's a lot of flexibility in how we implement those repositories.
There is. The key is to select an approach that aligns with your overall architectural choices and performance requirements.
Makes sense. It's all about choosing the right tool for the job.
Exactly.
Wow, this is fascinating. We've gone from grouping objects into aggregates to persisting them using repositories. It's amazing how all of these pieces fit together.
It is. But no software exists in isolation, right?
Hmm.
We need to think about how we integrate with other systems, other bounded contexts.
Integration. Yeah, that's always a fun challenge. How does DDD approach that?
That's a big topic, and the book dedicates an entire chapter to it.
Okay.
It emphasizes the importance of understanding what are called the fallacies of distributed computing.
Fallacies of distributed computing. Oh, that sounds ominous. What are we talking about here?
These are those assumptions that we often make about distributed systems that can lead to serious problems if we're not careful.
Such as?
Like assuming the network is always reliable, or that latency is negligible, or that bandwidth is infinite.
Right. In the real world, those things are never guaranteed.
Exactly. So it's about being realistic about the challenges of working in a distributed world.
And designing for resilience.
Exactly. Now, when it comes to actually integrating those bounded contexts, the book explores two primary approaches: restful resources and messaging.
Okay, REST and messaging, I'm familiar with both of those, but how do they apply specifically to integration in a DDD context?
So imagine you have two bounded contexts that need to exchange data.
Okay, like our ordering and customer relationship management context from earlier.
Perfect example. You can expose RESTful endpoints within each context that represent the relevant domain concepts.
So the ordering context might have an endpoint for retrieving customer information, and the customer relationship management context might have an endpoint for creating new customers.
You got it. And because REST relies on those standard HTTP protocols, it's a very flexible and widely supported approach.
Makes sense. What about messaging? How does that work for integration?
Messaging is all about exchanging asynchronous messages between systems. And this is where those domain events we talked about earlier can really come into play.
Okay, so for instance, when a new customer is created in the customer relationship management context, it could publish a customer-created event,
Right.
and then the ordering context could subscribe to that event and create a corresponding customer record on its end.
Exactly. Messaging is a great choice for creating loosely coupled systems where different parts can evolve independently without those tight dependencies that can cause so many headaches.
This is fantastic. We've covered so much ground today, from aggregates to repositories to integration. It feels like we've explored the entire DDD universe.
We've delved deep into those core principles and patterns. But there's one final layer we need to explore:
Yeah,
the application layer.
a final layer. Okay, I'm intrigued what mysteries await us in this application layer. All right, we're back, ready to uncover the mysteries of this application layer.
Let's do it.
So remind me again, what exactly is the application layer and why is it so important in the grand scheme of domain-driven design?
Well, you can think of it as the conductor of an orchestra, making sure all the instruments play together harmoniously.
Okay, I like that. The conductor, so it's about coordinating, not actually playing an instrument itself.
Exactly. The application layer orchestrates those interactions between your domain model and the outside world. But it shouldn't be bogged down with domain logic itself.
Right, that belongs in the domain model. We want to keep things separate.
Precisely.
Mm-hmm.
So it's responsible for things like managing transactions, handling user interface interactions, enforcing security, but it delegates most of the heavy lifting to the domain objects themselves.
Okay, so it's thin, it's focused on coordination, but how do we actually go about designing this application layer? What are the key components?
One of the most important is the application service.
Application services. Okay, tell me more.
They essentially encapsulate those use cases or user stories that drive your application.
Okay, so they're like the entry point for external clients. They receive requests and then orchestrate the necessary actions.
Exactly. So instead of having a user interface directly call a method on an aggregate, it would go through an application service.
Right, so it adds a layer of abstraction. It's like a middleman.
And it handles things like retrieving the appropriate aggregate from the repository, enforcing any business rules, validation logic.
Make sure everything's done in a controlled and consistent way. Now, you mentioned application services, but we also talked about domain services earlier. I'm getting a bit confused. What's the key difference between them?
Ah, yes. It's easy to get those terms mixed up. Remember, domain services are part of the domain model itself.
Right. They encapsulate domain logic that doesn't naturally fit within an entity or value object.
Exactly. Application services, on the other hand, sit at a higher level.
That coordinate those user stories, those use cases, those workflows.
Exactly. They often interact with those external systems like databases or third-party APIs.
Okay, so if calculating shipping costs is a domain service, placing an order would be an application service.
Perfect example. The application service for placing an order might utilize that shipping cost calculator domain service along with other domain logic to actually fulfill the order.
Okay, that clears things up a bit. So application services orchestrate those high-level workflows using the domain model and external services as needed.
Exactly. And when you're designing these application services, it's really important to keep them thin. They should delegate as much as possible to the domain model.
Right, avoid putting domain logic in there. That's a no-no.
Exactly. Now, when it comes to actually implementing this application layer, DDD is very flexible. You can use a variety of architectural styles, technologies.
So we could use that hexagonal architecture with ports and adapters to interact with the outside world.
Absolutely. And the book discusses patterns like command handlers, which work well with event-driven architectures.
Command handlers. Okay, what are those?
A command handler receives a command like place order and then executes the necessary logic to fulfill that command.
So instead of directly calling methods on application services, we send them commands.
Exactly. This creates that loosely coupled system where different parts can communicate without those tight dependencies.
This is fascinating. So those commands can be triggered by all sorts of things, right? Like a user clicking a button or a message coming in from another system.
Exactly. And the application layer handles all of that, orchestrating the flow of commands and events.
Wow. This has been an incredible journey into the world of domain-driven design. We've covered so much ground, from bounded context to aggregates to application services. If you had to boil it all down to one key takeaway, what would it be?
That's a tough one. But if there's one thing I hope you take away from this deep dive, it's this. DDD is about more than just code. It's about creating software that truly reflects a deep understanding of the domain it serves.
Beautifully said. It's about bridging the gap between the real world and the code.
Exactly. And I hope this deep dive has inspired you to explore DDD further. It's a journey of continuous learning and refinement, but the rewards are well worth the effort.
Agreed. So to all of our listeners out there, keep learning, keep experimenting, keep building those amazing domain-driven systems. And that wraps up another deep dive. Until next time, happy coding, everyone.